Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientist with me, Sue Marchant, and Dave Ansell. What have you got for us in the world of science?
Well, I saw an interesting story about some scientists looking into the private lives of mummies. In fact, one of the most famous mummies out there at all, Tutankhamun.
Yes.
Who was discovered in 1922 with his whole unmucked up by grave robbers.
Yep.
And Zati Hawass and Carsten Puch have been able to look at the actual mummy. In fact, not just Tutankhamun, but 10 other mummies who ought to be related to him.
Yeah.
And they've been x-raying the mummies in great detail with CAT scans and things.
Wow.
And they've been taking some samples from their bones and doing a genetic analysis on them.
Really?
And there's actually DNA surviving, partly because the Egyptians were so good at mummifying, there's actually quite a lot of DNA left. And they've been able to work out how he was related to the other mummies. So they discovered that his mother probably isn't Queen Nefertiti, who they thought he was, but another royal, in fact one of his sisters or half-sisters.
Really?
So everything was getting a bit incestuous back then, as we thought was happening. But yeah, they've now got the proof from the DNA evidence.
How scary is that?
I think you got more power. The more royal blood you had, the more powerful the child was, and the more like a god the child was. So they tended to do a lot of inbreeding Egyptian pharaohs.
Really?
They also discovered that all this inbreeding possibly wasn't very good for him because he had a genetic problem which caused bone necrosis, where there wasn't enough blood flow to the bones and they were all slowly dying in an incredibly painful condition. And so he couldn't walk properly. In fact, they found in the tomb lots and lots of walking sticks. And this was because he couldn't walk without help or without sticks.
Wow.
Only at the age of sort of 19. And they also found out they had malaria. They actually found DNA from malaria parasites inside his bone. And he had a broken femur. And they reckon that either the broken femur caused blood clots which killed him, or the malaria was some part of it. And so he wasn't a very healthy guy, really.
Gosh, that's amazing. Gosh, there'd be all sorts of curses and things that would be going with that now.
It's incredible finding out the information from sort of 1324 BC, and all that's still preserved in the bones.
That's just absolutely amazing, isn't it? Right, Dr. Dave, let's get on with our questions. And we start off with one here from Mike. One thing that's been puzzling him for ages, and that is, how does a meat tenderizer work?
Okay, I guess these are the powders which you can add and then sort of soak your meat in for ages, and slowly the meat gets more and more tender. There's lots of things which will work. One of them is pineapple juice. Not cooked pineapple juice, but raw pineapple juice works as a meat tenderizer.
Does it?
It's actually, if you've ever eaten lots and lots of pineapple and notice your mouth hurts at the end of it.
Yeah.
That's because in the pineapple there's an enzyme which actually breaks down protein. It's sort of like a digestive enzyme. And as you eat it, it starts to break down the proteins in your mouth. And that's why it starts to get a little bit sore.
Yeah.
And so if you put pineapple juice on a piece of meat, it will slowly break down the proteins in the meat, including the tough collagen fibres. So it will slowly get less and less tough as you pre-digest the meat a bit, and so it gets more and more tender.
Well, I didn't know about that. I knew about garam masala, the Indian spices that are good for tenderising meat, but I didn't know about pineapple juice.
Kiwi juice as well.
Kiwi
Kiwis
juice.
have the same effect, yes.
Ah, all right. Well, we've learnt something there. Let's go on to our next question for Dr. Dave, which is this one. Colour TV pictures suddenly gone all mauve and green. Can you explain why this has happened? That's from Sylvia in Gowley Wood.
I can't give you exact answers exactly what's happened. I can come up with a couple of possibilities. The way a colour TV works is you've at the front of the screen, you've got lots of little blobs of things called phosphors. If you look very close up against the screen, you'll see the blobs of different colours, red, green and blue. And those little phosphors glow. And the reason why they glow is they're getting hit from the back by electrons. A beam of electron is shot from the back of the TV. It's steered using a magnetic field, and it hits the front of the screen. And there's three different, they're called electron guns. One of them produces the red signal, one of them the green, and one of them the blue. And they've got to be very, very accurate because they've always got to hit a red blob. Otherwise, if they move slightly, then the one which you should be making red will make green. The one which you're making blue could make red, and you get colours all wrong, basically. So it's something has ruined the calibration of your TV set. It could just be the electronics is getting old and failing slowly, or it could be a magnetic field. In fact, with some old-fashioned TVs, if you pick them up and turn them upside down, it has exactly the effect you're describing, because the Earth's magnetic field is strong enough to deflect these electrons onto the wrong colour. They've only got to be deflected by less than a millimetre, and all the colours go wrong. And so if you pick up a TV while it's on, turn it upside down, ideally a small one, otherwise you'll do your back in, turn it upside down, the colours can go completely wrong. And if someone waves a magnet near your TV, it can do the same sort of thing. In fact, we did a kitchen science on it a couple of years ago.
Yeah.
Turning the TV off and on again, especially with more modern TVs, less than sort of 20 years old, they have coils in them called degaussing coils, which demagnetise the TVs so as it works fine in the magnetic field which you're sitting in.
Mm-hmm.
And that's a buzz sound you get when the TV turns on. There's a buzz noise. And so it could be that, or it could just be electronics. Basically, the calibration has gone wrong on the TV somehow. Try turning it on and off a few times is the easiest solution. Otherwise, I think you have to talk to somebody who actually can take it apart and have a look at it.
All right. Stephen Essendon has asked, how do the manufacturers and sellers of sparkling wine manage to insert the corks into the bottles?
I can't say I have any direct knowledge of making sparkling wine. I guess the problem is you've got this sort of conical shaped cork, which is a cone pointing in the wrong direction. I can only say how I would do it if I was building one.
Go on then.
What I would do is have a sort of metal cone which gets narrower at the bottom, which you put in just above the hole in the bottle. Then if you can sort of ram the cork into that cone, it will get narrower and narrower and narrower until it will actually fit into the bottle. And then once you get it in there, you can take away the cone and just jam it all the way in. I think you've just got to compress that bottom part of the cork until it will get inside the bottle, and then it should be all right.
Yeah, so change corks now. They get these squidgy plastic ones and things, don't they?
Ones,
So
yes.
change, and screw tops, of course, as well. All right, well, one here from Keith McNichols. He's wondering about explosions, wondering about what happens when either conventional or nuclear bombs are exploded in a relative vacuum of outer space. So how do explosions travel in space, Dave?
Okay, on Earth, if you have an explosion, what happens, you release lots and lots of energy, you produce lots and lots of gas, that compresses the air around it, and you get a vibration travelling through the air, and that feels like a shockwave. In space, there's no air, so all the gases which produced, they're still there, and they'll just travel out into space, just keep on going, it doesn't slow them down, and they'll just spread out incredibly fast. If you're in the way and you're quite close to it, you will get hit by those gases, and it will move you, but probably less strongly than the gases on Earth, because there's less mass there, especially if you get more than sort of kilometre away. There's going to be very little gas moving, so it won't produce a very big effect. And if you set off a nuclear bomb, the main way that a nuclear bomb produces all this hot gas is there's very little material in there to begin with, but it releases so much energy. You get a huge amount of X-rays given off and gamma rays. These X-rays make all the air around it very, very hot. And then that travels on as a shockwave. But in space, there's no air to make hot, so you would get a very intense burst of X-rays, which would travel out at the speed of light and carry on going and going. And if you were close enough, they would irradiate you or even heat you up or cause damage. So I think the radiation would be much more of a problem than any shockwave up there.
Right, Mike has said that on his patio he has a large container of birdseed, and when he lifts the lid in the summer, he finds silver trails left by slugs, and he wonders, how do they track down food that's 3 feet off the ground? How clever are slugs, Dave?
It's quite impressive. I would have thought it's to do with basically the sense of smell. The antennae are very sensitive to molecules, so basically they can smell food. I expect also they tend to wander around at random until they find something to eat.
We're going to go to the phones right now because Glenn is there. Hello, Glenn.
Hi, Dr. Dave.
Hi.
What it is, I'm a personal trainer in Northampton, and I watch like strongman competitions, and I've been doing it for a long time, weight training. But
Yeah.
I've always wondered, when they're pulling the 20-ton truck on the event,
Yeah.
and then they've got lots of wheels connected to the ground surface area, and then they pull a 747, which is 40 tons. When is it not 40 tons, if you know what I mean? When they get going, the initial pull is that 20 tons, and then when it gets going, the inertia is it.
Yes.
Have they ever weighed that?
Okay. It always weighs 20 tons, but the weight is pointing straight downwards, so the big strong guy isn't actually fighting that at all.
Yeah.
All he's doing is fighting the inertia, so you've got to give it energy in order to get it moving, and the friction. You're interested in the sort of rolling resistance of tyres, and that's around about 1% of the weight, which is pushing down on it. So if you've got a 20-ton truck, if the tyres are nicely pumped up, then it's probably only going to be producing a friction of 1/100th of that. So
Right.
maybe 200 kilos.
Okay.
Which is the reason why they can move it. And I could imagine that aeroplane wheels might, especially if they pumped up the wheels really well, you probably even get a slightly lower rolling resistance than that. So you're probably talking about similar sort of forces.
Yeah. Because I just noticed, on the event, on the 20-ton truck pull, they did 40 seconds over 25 metres, and then on the 747 big plane, they did 40 seconds as well, and that was 40 tons.
Probably they had better wheels on the plane. So
Well, there was less wheels, basically. That's what I put it down to. The truck's got more surface wheels.
yeah,
Train off the back as well,
basically you're interested in how much energy it absorbs by rolling.
Right.
So it's very dependent on how, if you've ever ridden a bike, if you've got flat tyres, it's really hard work to pedal.
Correct,
And so it'll depend how high a pressure they pump up the tyres to, exactly what the materials are and things like that. I could well believe that aeroplane tyres are much higher spec and probably have a lower rolling resistance than truck tyres.
So, and then last one, they've got another event where they pull a sled up a hill, up a gradient, 300 kilograms.
Yeah.
That would be probably pure 300 kilograms that they're pulling.
Not necessarily. If you're going up a slope, if it's a 1 in 4 slope, then you're pulling a quarter of its weight, roughly.
Right.
So if it's a 1 in 4 slope and he's pulling 300 kilograms and he's pulling 75 kilograms directly of the weight, plus whatever friction there is, and the friction on that is probably maybe half of its weight, maybe something of the order of that. So it's probably around about 200 or 300 kilos again in total.
Right. Okay.
Cheers.
That's great. Thanks for that.
Glenn, thank you very much, and take care.
Yeah.
Bye-bye. Bye-bye. If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Dr. Dave from The Naked Scientist. We've got one more question here. Why aren't all flying objects dimpled like golf balls? A good point, because they do fly, don't they, golf balls? Yes, very good. And that's from Gary Topple, who's in Felixstowe. Thank you, Gary, for that one.
Golf balls aren't dimpled because it does make them fly better, but it only works for certain speeds and certain sizes of object. If the ball didn't have any dimples, then the air flowing past it you tend to get very big little vortices, little whirlpools of air going behind it, and they absorb a lot of energy. With the dimples, it produces lots of small ones, and that causes these big vortices to start forming later, so you lose less energy and the ball goes further and straighter. And this only works for a certain set of speeds and certain sizes of objects. If you hit the golf ball twice as fast as you do normally, then it would actually be more efficient not to have any dimples at all. So aircraft are moving so fast in the regime where dimples aren't an advantage, whereas if you made a very, very small aircraft, then it's possible, and a very small, slow aircraft, then it's possible dimples would help. But just with most flying objects, they're not in a regime where it helps if you're going too fast.
All right, interesting stuff. So let's say good evening to Dom.
Hi.
Hi, you're through to Dr. Dave. What's your question?
Well, mobile phone signal boosters.
Yes.
That some of the phone networks are introducing.
Yeah.
How do they actually boost the signal, and how do they work?
I think certainly some of them I've heard of. Basically, they act like a little tiny mobile phone mast. So they'll accept the signal from your own mobile phone.
Yeah.
They'll then decode it, and they'll actually send it through your broadband cable to the phone company, which then routes it through the phone system and to the other person you're talking to. And so basically they have a little digital radio in them, a bit like a wireless hub at home, very low power, so it doesn't interfere with other people too much. It can pick up your mobile phone, and then it routes the signal through the copper wires from your house.
Dr. Dave is here in the studio. Mouse says, the TV colour problem, it may simply be that a younger member of the family has been experimenting with the colour and contrast controls. That's very true. Yes, life is one experiment, so they say, don't they, in some degrees. Dave in Great Yarmouth, who sent us an email. I've recently seen some vids of 3D holograms. How do they work? And can they be projected into space?
Okay, 3D holograms basically involve some way of meaning that the light getting to your eyes changes, the path of light changes as you move around it. So as you look at it from different directions, you see different images. If you can arrange it so that those different images are of objects, pictures of objects taken from different angles, then it looks 3D. Now, the conventional way of doing this is by using a laser You shine half of your laser directly at your film, and the other half you bounce off an object and onto your film. And then those two light waves, they interfere. So in some places they produce brighter light, in some places they produce darker light, and they make a pattern of light and dark on a scale of about 1,000th of a millimetre. So you get lots of dots of light and dark. And those dots happen to be in exactly the right shape. So if you shine more light at it, light bouncing off all little bits of light and dark combine and interfere to form the light which produced it. It's beautifully symmetric and it works lovely. And so you get that image. So basically you take lots and lots of exposures of an object in different places from different angles. And if you get all of the symmetry right, then it looks like the object's in 3D and you can move around it. And it looks in three-dimensional, and as you move around it moves around too. That only produces a two-dimensional hologram. If you're going 3D, you need something more sophisticated. You can actually produce that hologram, that pattern of light and dark. Actually, with the computer can work out where the light and dark ought to be, and it can kind of simulate the hologram effect, and you can produce a 3D moving picture. Whether you can project it, you certainly can't project it into the middle of nowhere because you need something to reflect the light off. Mm-hmm. You could have a wall which was made up of some some cunning hologram material, and it would look like the object was out in front of it. You couldn't project it onto a wall, onto a normal wall. The wall would have to be very high tech and be able to produce these beautiful patterns in order to get the effect. I think.
You think? All right, okay.
I'm sure some cunning engineer will, in 50 years' time, or possibly even 3 years' time, or tomorrow, will prove me wrong.
If they can do it on Star Trek, it'll happen. Believe you me.
There's some
all sorts of things
working on
happening
it in Cambridge at the moment. There's one guy who's using lenses to produce 3D TV.
See, we don't know half, do we? Let's go to Mike's question. Lots of mics everywhere. Thank you, Dr. Dave. I watched live football with the sound down and listened to the radio, and noticed the TV recording was at least 2 seconds behind. Why is this?
Probably because it's gone through some kind of digital stage. And a lot of the way the digital things work, they attempt to compress more information into a smaller pipe. So you're getting better quality images through a smaller pipe. That involves a lot of processing. That takes time. And sometimes you need the time because it wants to know, because it compresses it by knowing what happened before and after the image it's compressing. And so that takes some time, and by the time you compress it and decompress it, possibly a couple of times, it could easily take 2 seconds. If you're listening on digital radio, of course, that has a couple of seconds delay, and you might find that they're in time, or they might then the radio might be behind the TV. So yes, it's to do with digital compression and decompression, I think.
We're here, there and everywhere then. Tony is on the line. Hello, Tony.
Now, what I really wanted to know was, it goes on for infinity, doesn't it? Outer space.
As far as we haven't found an edge, yes.
No, not an edge, right. Is there anything in it? Is it dark matter, for example? Have we any idea?
Well, as far as we know, it's really quite bizarre. Essentially, the universe is basically full of stars and planets and gas and things. And as far as we know, that carries on. Either that could go on forever, or it might be a bit like our three-dimensional universe is actually the surface of a more dimensional, say, perhaps sphere or something. So it could be that if you went in one direction for long enough, you get back to where you started. A bit like if you walk in one direction on the Earth for long enough, you can get back to where you started. So it could be that the universe is what's called closed and it's sort of spherical-ish. Or it could be that you go off in some directions forever, and in other directions you get back to where you started.
Like a donut.
Could be like a donut. There's all sorts of possibilities. Cosmologists, some of them they think are more likely than others. Basically, all we know is that the furthest we can see is about 13 billion light years away, 14 billion light years away, which is quite a long way. And
it is.
And at that point, we don't see the edge of the universe. What we see is that basically, because the further away you look, you're looking backwards in time. We don't really see the edge of the universe. We just see the beginning of the universe. And near the beginning right at the beginning of the universe, it was really, really hot. And you basically get this hot plasma, and hot plasmas are opaque. Light can't go through them, and they're glowing really hot, and that's all we see in every direction at the moment. So as far as we can see, if you look as far as we can see, we just see the beginning of the universe. We don't see the edge. So,
I think I get that, yeah.
So as far as we know, the universe just carries on in every direction. We have no real knowledge of anything else.
But there is, it's not like, how can I explain? Like if you had a football in the middle of a field, and we're the football, our own universe, as it were, and from the Big Bang, the results of the Big Bang, the rest of it is the outside, the outside. So it's very hard to conceive it, isn't it?
It is. I mean, fundamentally, we don't really have enough information to answer that question.
No, because, I get.
Because it's sort of there are theories which involve other universes. Possibly there could be more than the 3 dimensions which we live in, and there could be other. So our universe could be a sort of maybe the surface of a 3-dimensional sphere inside a more dimensional space, if that makes any sense. So it could be like we're the surface of the football, and there's lots of other footballs all over the place.
Yeah, that was I wonder.
But to be honest,
we don't know.
We don't know.
It's too big.
It's too big, and yes, I mean, really, without looking, or unless either the universes have an effect on our universe, I don't know how we could ever know.
Rightio. Doctor, thank you very much.
Very, very deep question. Thank you, Tony.
Thank you, Tony. We're impressed. Take care. Bye-bye. Bye-bye. Bye-bye.
Bye-bye.
Malkin Lowestoft said he's just smiling to myself about Dave saying about the edge of the universe. He's often referred to as this, but no one will verify whether it's just an edge or just the unknown. It's all unknown. We've no idea what's going on. It's one big experiment. Really, it's the Matrix, isn't it, Dave?
Who knows? Perfectly plausible. It's a perfectly consistent explanation that we are living in some kind of computer game.
Well, right.
It works. All the universe could have started 2 seconds ago in order to look like it was 14 billion years ago, but it certainly looks like it was made 14 billion years ago.
All right.
Or something exciting happened 14 billion years ago anyway.
One last question then. David, he says, if a photon is supposed to have a zero mass, why is it that a laser can produce heat?
Photons are little particles of light. They seem to be, light appears to arrive in little lumps. We call those little lumps photons. It has some properties of a wave and it has some properties of particles. And when we're thinking of it as a particle, then we call them photons. As far as we know, they have no mass if they were stationary. But they're not stationary. They're moving at the speed of light. And anything moving at the speed of light should have an infinite amount of energy per unit mass. Because 0 times infinity can equal anything you like it's undefined. And it appears that photons have an energy related to their wavelength and therefore, in some senses, a mass. So if they're moving, then they have a mass, but if they're stationary, they have 0 rest mass. Photons definitely have energy. If you go out and lie in the sun, you're getting hit by lots of photons and it warms you up. And so exactly the same way, laser light, all these photons have got a load of energy. They're little vibrations. They hit the atoms in your skin. These little vibrations cause your atoms in your skin to vibrate, and so they get warmer.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.